Thank you. And just a plug for Leaf, if Nick and Boz are still here. Yeah, I use Leaf all the time. So I actually dive in when I need a quick query. It's my favorite go-to tool. And thank you, Peter, for giving me credit for building the dog. But let me just say, I did not build the dog. A lot of really talented people who work for me built the warehouse. So I want to give credit where that's due. It's been a great afternoon. I, sort of thought I would have completely redone my slides if I had time after listening to everybody. It's super interesting. I have no relevant financial relationships to disclose, so just want to sort of say this. And I also want to give credit. Sean Mooney and I originally developed a version of these slides that we presented last fall at UGM, and we presented at a couple other places, and so I've harvested those for this talk and made some updates. So just quickly, going to talk about a little bit of background, then talk about how we do governance around real-time clinical models, talk about how model development and validation happens, and then some lessons learned. And Peter, how much time do I have left?
You've got 14 minutes.
Okay, great, thank you. Just trying to track that. So a little bit of background around predictive models at UW Medicine. And my talk is not focused on all of the fantastic data science that happens at UW and UW Medicine, but really on real-time clinical and operational models that are running against our EHR, right? So how do we really take that and leverage that to impact patient care? In spring of 2021, we implemented a new EHR. We went fully onto Epic. And as part of that, there was a lot of interest in Epic's out-of-the-box clinical models, as well as what's known as Epic's cognitive computing capabilities. So we had been working to get those enabled, but not in production use, but just to make sure that we had the technology enablement behind that, the architecture enabled. And there were really a lot of concerns about this at UW Medicine. And so we have executive data and analytics governance, and they gave us direction to create a predictive analytics oversight committee, which I'll refer to as PAOC probably, which was really charged to build, okay, we need an operational model for this. We had a lot of discussions about this. Going to talk a little bit more about how this committee was formed. Oversight included new model intake and priorities. How do we evaluate models, including for performance, bias, systemness, and provider impact? Ongoing model review and monitoring, technology tools and support, predictive analytics strategy, and investment. So we formed this committee as part of a larger governance committee, so it had the appropriate sort of alignment and sort of reporting structure, sort of a summary of that. Created a new council. The council had largely clinically led. Clinical co-chair, I'm one of the co-chairs. A lot of clinical leaders, QI leaders, research and School of Medicine, CMIO, CNIO, and really started sort of tackling this. So this was really prior to even go live when we formed the committee, and spent many, many months working on a process for how we would move a model from an idea through production and into kind of an operational phase. So we had a couple guardrails. One of them was that we would not activate a model for real-time production use without appropriate clinical engagement and review, that we would collect sufficient training data, and that we would make sure that we were reviewing this against existing decision-making protocols for clinical decision-making and IT governance, right? So there's just a lot of coordination and communication that needs to happen with these models. And then, so here were the phase that we identified. Ideation. It's our first phase. That's really can be just a model can come in from anywhere. It could be a custom model where somebody has an idea. Could be an Epic model. Either way, this is where sort of that initial conversation happens. There's a validation phase. Then after that, a lot of times in ideation, you have data that's not UW-Medicine data. It may not even be EPIC data. So what you want to do is start to look at that and say, okay, let's validate. Do we actually have this data in EPIC at the time when someone wants to make a prediction? Is there a relevant intervention, right, that we might actually take that would be meaningful? Really sort of have to go through and do a lot of work with our EPIC team, with our clinical partners to understand what that looks like, and then what we do is we build a pilot. One of the things we identified is we really need to pilot these, right? We need to have a small group, we need to understand what we want to do so that we can see what actually happens in that clinical environment. So this is where we really engage with the rest of the ITS governance, because pilots require a lot of different resources, right? I mean, it's not just our data science team, it requires usually the EPIC application team members, clinical resources, clinical informaticists, a lot of different resource and coordination we want to make sure that we implement. And then during the pilot is when we look to collect information, real information about performance, about impact to the provider's overall experience, how it fits into kind of the larger clinical experience that's happening. If you have a model that's alerting a lot and you already have a lot of alerts on patients, that just becomes noise, right? So you have to think about what you're doing in context to that whole clinical experience. But if you can make it past there, then we can go into implementation and actually implement the model fully, so usually with some adjustments that you've learned from your pilot. And then the last thing you want to do is move into an operations phase. The important thing about the operations phase is you don't just, implement and forget it, that you actually set up regular auditing and data collection, and so you're continuing to actually review model performance, because you can have model drift, you can have data drift, you can just have clinical care drift, right? It's all moving all the time. So for every model that we look to move past validation, we look to build a model oversight team. That's formed by we need our clinical and operational champion. We need to make sure that we have an authorized decision maker. So sometimes we'll have somebody who has a great idea, but they may not actually be authorized. So we have to work to make sure they're connected to the right people who are authorized, so that we sort of, get that engagement in there. We may have additional subject matter experts that are needed. Usually this is 3 to 5 team members. We have our data scientist and data analyst, the EPIC application team members, and sometimes a clinical informatics member. And they're kind of our shepherds throughout this whole process. Evaluation. This is actually really the tough one. I'll kind of be honest. We've spent a lot of time trying to figure this out, and we are still working on this. How do we actually evaluate a model's performance when we think about whether or not to move forward? We're looking at positive and negative predictive value. Both matter. We want to make sure that the model is actually actionable. Does it predict something that we can do something about? Right? And because otherwise it's just noise, and the EHR is already noisy. And is the intervention useful? So I'll give you an example. No-show is an interesting model, right? Because patient no-show is something we definitely want to be able to predict and do something about. What are you going to do if it predicts that someone's going to be a no-show? Are you, because we already text people if they allow that. We already have, a lot of different kinds of patient reach out that happens. So what are we willing to do? Are we willing to have people do a softer handoff, right? Where we reach out to somebody and we call them, right? What are we willing to do? Are we willing to send an Uber for somebody? Are we willing to overbook, right? Well, what would that look like? What's the impact of that? If we're not really willing to do any of these additional interventions, it's just not worth the time to bother to predict a no-show. The other thing that we do, that we found that we need to do, is out of the box, the results that you get tend to be summary data. So we've had to do a lot of work to join the results with patient data so that we can do deep analysis and understand how this actually performs at the departmental level, so we can go back and understand performance. It's also where we get patient demographics, so we can understand whether there's bias in the model, right, that's showing up. Shows up a lot in models that use payer. Actually, turns out we found a lot of bias if payer is one of the features. So we wind up taking payer out of a lot of our models. And then we have to look at overall impact, right? It's not just this one model, it's everything else that's happening. How often is the model being acted on? This is why I think pilots are so important, to understand what the actual experience with the model is. How often does the alert fire? How often is it acted on? How often is it ignored? Are there provider differences? Are there departmental differences? Really want to kind of understand the overall impact of the model. And Epic Slicer Dicer, people were asking about it, but here's a pitch for Slicer Dicer. It's a great source for BPA analysis. So we'll go in. You have to kind of go and pull the data from different places, but you can go and look to see what's the overall BPA experience that's going on. So what have we learned so far, kind of in this journey? And we have a lot more to learn. Having engaged clinical champions is crucial. We will not move forward with a model unless we have engaged clinical champions who are looking at this. We need to have people who understand what that experience is with the patient, with the clinician, and can really provide advice about whether or not this model has value and how we might need to adjust the model. And frankly, even helping us to interpret the model. Like, we'll have a model that seems to work in 10 departments but falls apart in 15 other departments. It's like, is the workflow broken, or is it, and they're like, no, it's just that the way this department works, it doesn't make any sense. And you're like, okay, fine. And then you can go and adjust and turn the models off for some departments, and then you go back and refine it with the departments where it makes sense. One of the things we learned is that we have to pay attention to model behavior early and often to identify configuration and other issues. We turned on 15 models in the background at Go Live. We went and looked at them a couple months later, and none of the models were configured correctly. So, and it's nobody's fault. It's just that they're really hard to configure. They're really twitchy, frankly. That's my technical term. You have to really go and look hard at the features. Is the data populating where you think it's populating? It's a bit of work to get them working. And then we have to make sure we build that into our operational review. We need to run the models for a period of time to collect data for never events. If things don't happen very often and we need a lot of data to evaluate the models, we may have to run a model for a year or more. They are a lot more work than we thought they'd be, honestly, so far. Now, some of this is architecting and having to figure out how do we get the patient-level data, because we have to go reverse engineer that, because it's not really easy. It's not really being provided, but it's a lot of work. So we need pretty strong business and clinical cases for a predictive model. Bias in data leads to bias in model performance. I know that's a duh, but it's true. And custom models are really hard. Epic models, out-of-the-box models are interesting, but custom models are really hard, a lot of work.
So I'm Patrick Davis. I'm the lead Epic research analyst at UW-Medicine. I'm going to just sort of quickly go through kind of integrating with the electronic health record, which in our case is Epic. So start off, this is our team right now. Small but mighty, it's myself and Mark Todd. We are getting more people. Kind of what we do, we have two sort of main focuses, sort of enterprise or research infrastructure, as I call it, and that's sort of maintaining things at the enterprise level. So study coordinator access, release to monitor, sort of those high-level workflows that every study team uses, which becomes relevant because then we become experts in actually how the research is done. And then secondarily, and much more interesting in my mind, are study-specific projects. So we create custom data capture tools, integrations with external systems, and then just a whole pile of anything else you can think of, dream of, et cetera. To kind of go through quickly, I'm going to quickly talk through 3 different projects that we recently worked on that kind of highlight some of the things that we work on to show actually how they feed into ultimately some of the downstream data systems that can then feed predictive models, et cetera. So one of the projects that we were recently tasked with was a vascular surgeon wanted a registry of all the patients. They were collecting a note over time. Every single patient had a consult note, and so in talking with them, we basically said, hey, we can add discrete data so that when you pick the selections in the note, that data will then flow, and we can put that in a REDCap project. And all of this will sort of come relevant soon. Another project we worked on, we generated actually calculated data. An investigator came up with 10 domains that determined if a patient would be likely to develop PTSD. And so there's a scoring system where we essentially calculated in real time these 10 categories and gave them a 1 to 10 score. And then they picked the people that have a score above 5 and approached them for recruitment into the study so that they could give them additional treatment. And then additionally, some of the other things that we do is we implement clinical decision support tools. Part of why the other 2 examples are relevant is we both use existing data, we create new data, and then we use that to deploy clinical decision support tools that we can then target based on locations, providers, basically anything that exists discretely within the EHR, we can then build some sort of alerting tool or external integration on top of, which is kind of neat. And then ultimately everything then flows downstream into the analytics systems so that we can report on everything. Just a little plug for a lot of why the EHR-based implementations are useful, because it's really easy to transition from a research trial to then an actual standard of care workflow, because you've already done a lot of the heavy lifting of getting data collection workflows in the system. So then from there you can really easily implement it for standard of care. And that is it. If you're interested in any EHR integration, talk to Mark. Thanks.